Hello everyone, today we gonna discuss about CBC. CBC stands for Cipher Block Chaining. CBC is one of the mode of operation for a block cipher. It is an algorithm that uses a block cipher to provide information security. The idea of CBC is to use the previous block to impact the next block. It is suitable for the secure cryptographic transformation, encryption and decryption of one fixed length group of bits called a block. We use as an initialization vector for the starting block in CBC. We will discuss about CBC mode using DES block. First, we start from the encryption of CBC. As we used the DES encryption standard, the plaintext will be broken into several blocks with the block size of 64-bit. If it can't be divided equally, we may need to add padding to the last block. In this example, we use a plaintext with 160-bit size. It will be broken into 3 blocks. Each block must have a block size of 64-bit. However, the third block is only 32-bit. Hence, we will add a 32-bit of padding into the third block to fulfill the standard block size. Total of 3 plaintext blocks with the block size of 64-bit are formed. At the first plaintext block, initialize vector, aka IV, is used to perform XOR operation with the plaintext block 1. An IV is a random generated stream of characters. It is only used for the starting block. The size of IV is depending on the type of the encryption method used. At this case, is 64-bit. IV is not a secret value, but it needs to be unpredictable and different with the DES key. After the XOR operation is done, a 64-bit of input block is produced. It then enters the DES encryption. DES requires a 64-bit key to perform the encryption. A 64-bit of output block is produced after the encryption process is completed. It will be the ciphertext block 1. The output block will be passed to the next step, which is plaintext block 2, to replace the role of IV, used to perform the XOR operation in plaintext block 2. For the plaintext block 2, we use the output block 1 from the previous step to perform XOR operation. The following steps are the same. A 64-bit of input block is generated after the XOR operation is done. The DES encryption then encrypts the input block using the DES key, and produces a 64-bit of output block. It will be the ciphertext block 2. The output block will also be passed to the next step, which is plaintext block 3. In step 3, everything goes the same except the output block will not be passed to the next step, because this is the final step. Finally, we will combine all these generated ciphertext block and form a completed ciphertext. Now, we enter the decryption part. Again, as we are using the DES block cipher, we break the ciphertext into every 64-bit block size. Based on ciphertext we generated from the previous slides, which has a total of 192-bit block size, we break it into 3 ciphertext block, where each of them has a block size of 64-bit. The ciphertext block 1 enters the DES decryption function and passed through the DES decryption process using the DES key. An outcome of 64-bit output block is produced. The output block will undergo XOR operation with the IV that used in the encryption phase. The completion of XOR operation will then produce the plaintext block 1. The 64-bit of input block 1 will be passed to next step, to replace the role of IV, used to perform the XOR operation in ciphertext block 2. The idea and way to decrypt ciphertext block 2 goes the same as ciphertext block 1, except we use the input block 1 comes from the ciphertext block 1 to perform XOR operation with the output block 2. Plaintext block 2 is produced after passing through all the process in step 2. Again, the 64-bit input block 2 will be passed to step 3. We apply the same process into block 3 and produce the last plaintext block. After completing all the decryption steps, we will notice the plaintext block 3 contains some unmeaningful characters at the end of the plaintext. They are the padding that we added in at the beginning of encryption phase. We need to remove the padding, thus, we can combine all the plaintext blocks to present back the complete plaintext. That's all for today, thank you.